This is Geometry Unit 12, Lesson 1 on circles and arcs. A circle, by definition, is the set of all points in a plane that are equidistant, or at the same distance from, a fixed point. So if we have a point, fixed point here, and we have all of the points that are equidistant from it, here, 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 and if I put all the points, I have created a circle. The fixed point is the center of the circle. And the circle is usually named by this point. So this would be, the name of the circle would be circle C. A lot of times circles are named by O as the center. So this could also be circle O, if O was the center point. So the distance from the center of the circle to any point on the circle, here to here, I could draw another one here to here, any value like that I draw, I am actually drawing the radius. It's the distance from the center of the circle to any point. So if they are all equidistant, what does that tell us about any radii that we draw? All radii of a circle are congruent. So I can draw any radius that I want in this circle. I can draw one here, I can draw one over here, I can draw one down here, and all of these radii will be congruent to each other. Now, two circles are congruent if their radii are congruent. If they have the same length radii, then they have the same distance from their center. They must be making the same circle. And the degree measure of a full circle is 360 degrees. So that's basically what the main parts of a circle. All right, now let's talk about different parts that we have on a circle. The central angle. Central angle is any angle whose vertex is the center of the circle and whose sides are radii of the circle. So if I take my center of my circle and I draw two radii out anywhere on the circle, I have created a central angle. This angle right here, usually called theta, is the central angle. The vertex is at the center of the circle. Now the endpoints of the circle, right here and here, make 2 points on the circle. It's called an arc. It's the part of the circle between 2 points on the circle. So if I'm looking at this circle right here, I have some points, A, B, C, D, that are on the circle. An arc is named by any 2 points that create the arc. There's different arcs formed. A minor arc is any arc whose central angle is less than 180 degrees. So if you have an angle that is less than 180 degrees, 180 degrees be half the circle, an arc created like this from minor arc, for example, A to B, like this, that is less than 180 degrees. If I put in the radius right here, that arc right there is less than 180 degrees. So the minor arc we would name AB is a minor arc. Okay? Notice it has a little arc symbol over the top of it. That is the distance from here to here. Okay? A major arc is any arc whose central angle is greater than 180 degrees. Usually when you have a circle, if you have a minor arc, the major arc is the other way around it. So the major arc of this circle usually uses the third point to tell where it is, in which direction. So I could say that my major arc on this circle, if this is the minor arc, the major arc would be going in the opposite direction. And it's usually named by the endpoints with a letter in the between. So this could be arc, major arc A, and I'll say D, B. These are the endpoints. That's a point in the middle. It indicates direction. That indicates that this is the major arc rather than the minor arc AB. So this has no point D between it. This one does, to show that it's the one on this side, not on this side. So minor arc, major arc. All right, a semicircle is an arc whose degree measure is exactly 180 degrees. Its endpoints create the diameter of the circle. So there are actually 2 semicircles formed here. What is one? Well, the diameter would be here with A and C. So we actually have 2 semicircles. We have semicircle ABC, and we also have semicircle ADC. It's the other one going over here. Now notice I put the B and the D in there so I know which one I was doing. the degree measure of an arc. Now, degree measure of an arc is equal to the degree measure of the central angle that it intercepts. Degree measure is not the same as arc length. The degree measure of an arc is how much the rotation degrees is of the arc. The arc length is the actual physical distance from A to B. So they're two different things. You have to be really careful about that. Okay, so congruent arcs are two arcs of the same circle or congruent circles that have the same central angle measure. Basically, two arcs that intercept the same central angle. Okay, so if I look at these two circles right here, obviously these two circles are not congruent because one is smaller than the other. However, they have a congruent arc because they intercept the same congruent angle. If I look at my central angle right here, it creates an arc on this circle of AB. So arc AB, degree measure, will be congruent to arc YZ right here. Notice because the radius here and the radius here, they're both intercepting the two circles with the same central angle. So AB will be congruent to YZ for angle measure, or arc measure, excuse me, degree measure. Because they intercept the same degree measure here, that angle is the same for both this and this rotation. All right, congruent central angles intercept congruent arcs and vice versa. All right, so if the measure of angle AOB here and the measure of angle COD are here, what does that tell us about arcs AB and CD? Well, if those two central angles are congruent, those two arcs they intercept are congruent. So if AOB is congruent to COD, then arc AB is congruent to arc CD. And vice versa. If CD and AB are congruent, then the measure of AOB will equal the measure of angle COD. So if you have congruent central angles, you have congruent arcs. And if you have congruent arcs, you have congruent central angles. All right, now that we have the vocabulary down for circles, arcs, and central angles, let's see if we can do some work with them. We have circle O, where the measure of arc AB is 70. So the measure of this arc right here is 70. And OB is perpendicular to OC, OB being the radius. OB and OC are perpendicular, which means that they create right angles. Okay? Now, we want to find the measure of arc BC. Okay, so what do we know about arc BC? Well, the measure of an arc is equal to the measure of the angle it intersects. So it intersects the radius of the circle that are created right here. So that is the central angle. So the measure of arc BC is going to be 90 degrees. Because central angles intercept congruent arcs. So this is going to be 90 degrees out here. Okay, what is the measure of arc AC? All right, AC would be from here, let me do a different color, from here to here. Well, the endpoints of the radius are here and here, so that would be equal to that angle, or excuse me, these two arcs added together. So it would be 70 plus 90 is 160 degrees. Okay, so that is AB plus BC. That's where that came from, 70 plus 90. All right, the measure of arc APC. Now notice this has a P in the middle of it. That's indicating direction. So arc APC, A to P to C, is this arc right here. Okay, now we don't have any information about any of the arcs over here, but we know that this part of the circle is 160 from A to C. The minor arc is 160, so that means we're looking for the major arc over here. Well, how many degrees are there in a circle? There's 360 total, and we take out arc AC, I should say what we just figured out, and we're left with arc APC. Okay, so this would be 360 minus 160, because that was from here to here, and we end up with 200 degrees. So that is the measure of the arcs and the angles. Okay, now just for argument's sake, what would be the measure of AOB? Well, the measure of AOB would be equal to the measure of the arc. So if this is 70, this is going to be 70. And what would be the measure of AOC? This angle right here would be 200, because this one is 200. Arc length measure is the same as central angle measure. Okay, so let's look at our information here and see what we can conclude about these problems. In circle O, the measure of angle AOB is 70. AOB is 70. Since it has an O in it, that tells me this is a central angle. AB and CD, arcs AB and CD are congruent. This arc is congruent to this arc, and the measure of arc BC and AD are in the ratio of 3 to 8. So it's some multiple of 3 and 8. So I'm going to make BC is going to be 3x, and AD is going to be 8x, is this one over here, from A to D. Okay? All right, so we want to find the measure of angle BOC. Well, since this is a central angle, or excuse me, an arc here, BOC is the central angle that intercepts arc BC. So whatever BC is going to be what angle BOC is. So we need to figure that out. All right, so let's see if we can figure out what BC is. Okay, so we know AOB is 70. Well, if AOB is 70, that means it intercepts arc AB is going to equal 70 as well. So there we go. Now we know that AB is congruent to CD. So that means CD is 70. That's going to be 70. Okay, so now we have measures for all of the arcs. All right, we have AB, BC, CD, and DA. We have all 4 arcs there. What is the total arc going to add up to? If you add all those arcs together, AB plus BC plus CD plus DA will add up total to be 360 degrees if I add all 4 of those arcs up. So let's see. AB is 70, BC is 3x, CD is 70, and DA is 8x, and that equals 360. So that gives me 11x plus 140 equals 360. So 11x will equal, subtract the 140, 220. So x is equal to 20. Okay, so that means that BC is going to be 60 here, and that means the measure of the arc is equal to the measure of the angle. The measure of BC is equal to the measure of angle BOC, so that's going to also equal 60. So that angle right here is going to be 60. So if you want to check it out the rest of them, this one would be 70. This one would be 80 times 20 is 160. This would be 160 as well. Add them all up. 60 and 160 is 220, plus 140 is 360. So there we have it. So that is about arcs and angles of central angles of a circle.